So in this video, we're going to go over what an arithmetic sequence is and kind of how we can, write out an equation for it. But before we do that, let's talk about what a sequence is. A sequence is just a set of numbers that have a particular relationship. And that particular relationship could, of course, also be described as a pattern. And so we can formalize these into what are effectively functions so we can predict different numbers in the sequence. So let's look at an example of an arithmetic sequence, and then we can talk about its characteristics. So this is an example of an arithmetic sequence. Now, one of the first things I'm going to do is just write down which term is which. So the 4 would be the first term, the 7 would be the second term, and so on. And in doing so, we've basically written these out like points. So we have an input of 1 and we get an output of 4. We have an input of 2, we get an output of 7. Okay? And that'll become important later because we're going to see that this is really just a linear relationship. Now we know it's linear because if I want to get from 4 to 7, I just add 3. And if I want to get from 7 to 10, I add 3. And if I want to get from one term to the next in any of these, I'm just going to add 3. So this is what is called a common difference. Now, when we're talking about lines, there's actually another name for it, and that is the slope. Okay. Although I will say these aren't entirely the same because the common difference refers to always going up by 1 unit. And I'm digressing a little bit, but if you've worked with lines already, this is a really easy way to understand what we're going to kind of do here because we are actually going to basically derive point slope form. All right, so the whole idea of this is if I, for example, wanted to know what the 6th term is, and I'm just going to write it like this. We say a of 6. Well, I could just start at the first term here, 4, and then I have to add 3 a certain number of times. So if I want to get from the first term up to the 6th term, then I'm going to have to add 3 1, 2, 3, 4, 5 times. Well, that's interesting. I've got a 1 and a 6. Well, the way to count the number of steps in between 1 and 6 is just 6 minus 1. So in other words, I have 6 minus 1 3s. And so this is kind of how we would find this for any of these. Okay, if I basically count the number of steps, and we're just going to do it from that first term each time. And so if, for example, I wanted to do the 5th term, it would look like this. So I'm going to start at 4 once again, and then I just need to add, since I'm going to the 5th term this time, I'm just going to add 5 minus 1 of those 3s to it. Now, for some of you, I hope you know where I'm going with this. If I want to know what a of n is, well, that's the nth term. So I can actually just do basically what I did here, write out everything that hasn't changed. And if you notice, the things that haven't changed are the 4 was always there because I was starting at 4. And the 3, that's my common difference, has never changed. The only thing that changes here is that I know that I am counting from n to 1, or from 1 to n. This piece right here is giving me the number of 3s each time. And since I'm going to n, in this case, I'm going to have n minus 1 steps. Now, one thing I want to point out is the notation I'm using here is more of a function notation, and it works just fine for this, but it is not generally how you would write these. You generally write them using subscripts. And so the first term, for example, here would be a sub 1. And the nth term here would be a sub n. So for example, these pieces here, I could just rewrite as a sub 6, a sub 5, and a sub n, where the subscript is the term that we're talking about. And as I mentioned, I want to make sure we have a clear definition of what an arithmetic sequence is. And an arithmetic sequence is just a sequence whose terms increase by a common difference or a common amount. And that is the basics of how you can find the equation or formula for an arithmetic sequence when given a few of the terms in that sequence.